Hello everyone and welcome to another video. So today I'd like to do a quick video talking about this little guy. So this is a miniature portable battery powered GPS logging system. So it's basically created out of an Arduino Nano and a few other components like a GPS chip and some temperature sensors. And what this is going to allow you to do is basically create a portable system which can know its position, log that position, as well as log things like sensor measurements such as temperatures. So this is helpful for lots of different applications. In my particular case, we've got a small science club and we are trying to launch a high altitude weather balloon, and we would like to be able to track and record the position of that weather balloon as well as track the internal and external temperature of the payload box on this weather balloon. So that's what this little unit is for. So what we would like to talk about today is look at the circuit diagram, talk a little bit about some of the software that we're putting on board this, and then show you how to actually construct it. So if that sounds like fun, let's go ahead and get started.
Alright, so I thought the easiest thing to start out with was a simple wiring diagram of the overall system. So as you can see, it's based around this Arduino Nano that I've got down here, and really there are only three major components to this. So we've got a GPS module over here, so it's a U-Blox Neo 6M. I'll show you that a little bit more closely in a second. But really it's just a GPS chip hooked up to an antenna. So we can get position information out of this thing. We also have a pair of these DS18B20 temperature sensors. So I've got two of them hooked up down here. So really all I really care about with this GPS logging system is getting the position as well as two temperatures. And then what we're going to do is we are going to write that to a MicroSD card over here. So there's a little Adafruit MicroSD card over here. So what these components look like in a little bit more greater detail is, tell you what, let me pull up this page. So here is the GPS, and actually tell you what, let me see if I can move these over one on either side. Maybe we can try to get a better look at the different components and what they sort of look like in greater detail. So yeah, here's the GPS basically chip and antenna together. I buy them as one unit. It's about $25 as you can see here. You can see from this picture that this is right here. Yep, it's a U-Blox Neo 6M GPS module. And really, there are just a few connections to it. So if we look at this connection, there are 5 pins, right? Starting from the bottom, there's a power, and then a ground, then a TX, and an RX. And actually, we don't use the PPS. So if you look at the wiring diagram over here on the left, you'll see that basically we're just going to hook up the TX and RX of the GPS module. Actually, instead of hooking it up to the normal TX and RX over here on the Arduino Nano, we're actually going to use a different library to hook it up to digital 3 and 4. And again, I'll talk about that why in a second when we look at the code. But you're going to see this makes it a little bit easier to program the module, or excuse me, to program the Arduino, okay? Okay, so that's the GPS. Let's take a look at the other issue, the other components. So here are the temperature sensors, these DS18B20s. I bought them in a pack of 5. As you can see, they're pretty reasonable in terms of price. What's interesting about them is, again, each one of these have 3 connections. You can see right here, just a ground, a power, and a signal. So that's what I've got over here: ground, power, and signal. And then again, notice that this actually uses this one-wire bus system. So the signal for both of these temperature sensors go onto a common row here. And I've got a pull-up resistor here hooked up to power, but then the signal basically from both sensors go into just digital D2 in the Arduino. So I can basically read temperature sensor information from both of these two sensors on a single pin. So that's pretty neat. Okay, and then lastly, we've got the microSD card reader up here. Again, you can pause the video if you want to see the pinouts and how we hook this up. But again, I just got this guy off of Adafruit for, yeah, $7.50. Pretty simple. You can see it does have a bunch of connections that need to be made, but it's pretty straightforward. Just follow the wiring diagram over here. The other thing that I did add was I added 2 LEDs. So I added a blue and a red LED. So excuse me, this one is supposed to be blue. I just couldn't change the color in fritzing, so I've got 2 LEDs here. But all I want to do is I want to use these 2 LEDs, obviously hooked up through these current limiting resistors here, about 680 ohms. But I want to use these 2 LEDs to be able to indicate the status of the overall system, okay? So what might be helpful though is let's take a look at maybe the wiring diagram here on the side, and let's look at the actual Arduino code that I'm going to be loading onto this on the other side of the screen. Alright, so let me pull the code down from my other screen so we can look at them together. I'll put that on one side, put this on the other side. Okay, let me see if we can do this. Okay, so as you can see, let's just start walking through this and take a little bit of a look at it. So over here, pretty simple, nothing too much to talk about in terms of interfacing with the SD card. I'm going to be using this SD library here to talk with it, and obviously I just need to define which pin is the card select pin. So you can see I've hooked that up to channel 10 or digital 10 on the Arduino. The other thing to note is when you're naming the log file that we are going to be writing to this, I've discovered that you actually have to keep this name pretty short. If you add too many characters, this library seems to choke and you might run into issues. So again, name your file something small. So I'm just calling it log7, I guess, log07.csv. I'm going to be writing a whole bunch of CSV lines out to this, okay? So that's the SD card interface. Let's take a look at some of the constants that we're hooking up for the 2 temperature sensors. Again, these DS18B20 temperature sensors. So as we mentioned, we are using this one-wire system. So I'm going to use the one-wire header library, as well as there's this Dallas temperature library, which is great for reading and getting temperatures off of these sensors. So we're going to put those 2 here. And again, you see that we only need a single wire for this to read sensor measurements from both of these. So again, I've hooked these up to D2 here. So all we need to do is basically just set up the one-wire instance to communicate with the one-wire devices, those 2 of them, and then we are going to pass a reference to that to the Dallas temperature library. So again, I mostly copied a lot of this code for this off a really great blog post, which I will put a link to that blog post in the description of this video. Okay, now let's move on to the GPS module. This is where it gets a little bit interesting. So we're going to be using the Tiny GPS++ library to pull a lot of information from the GPS to parse some of these sentences and all that kind of good stuff. The other thing that's critical is this software serial library. So the GPS is usually doing communication over serial for RX and TX over these 2 lines, right? So normally your Arduino has RX and TX here on 0 and 1, right here on these 2 pins. The problem is these 2 pins are also share a wire on how the USB programs the Arduino. So if you plug in these RX and TX from the GPS into 0 and 1 on your Arduino, and then you also hook up the USB and try to program it, the GPS is going to interfere with these signals, and you basically are going to have a lot of problems trying to connect to and program and push up code to your Arduino. So some other systems, you actually have to unplug the GPS, and then you can use the serial programming via USB to program your Arduino. Then once you put the code on, then you re-plug in the GPS. Well, that works, but it's a big pain in the neck because you got to unplug, replug, do all this kind of stuff. So there's this software serial library which will allow you to basically make other ports on your Arduino act like serial ports. So that's what we're doing right here. So we are going to use pins 3 and 4, as you can see, to act like serial ports so that we can communicate with the GPS on separate pins, therefore leaving our this RX and TX on 0 and 1 free for the USB. So long story short, I can leave the GPS plugged in and still be able to program the Arduino using the USB for development. So this is pretty critical and pretty useful. The other thing to maybe note is that for example, take a look at the orange wire here. So the orange is hooked up to the GPS RX, right, or transmit. That goes into D3, which is the actual pin for TX or transmit. So again, you kind of got to cross the two wires here, but again, you can read a couple of blog posts or documentation on the GPS serial, and you'll see that, yeah, you kind of got to do this little cross connections, okay? Then after that, I guess this is my own custom library that I did to kind of do some additional functionality, but you know, it's pretty simple. I'll leave a post to all of this code, and I'll leave a link to it so you can download this as well if you want to just quickly flash this onto your machine. Okay. So then let's talk about what else we got to set up. Oh, our two LEDs are red and our blue LEDs. Again, nothing really too fancy. I've just got them over here on these two channels, A4 and A5. And then I'm going to set up some Boolean variables so I can flash these and I can understand if it's on or off. So nothing really too special there. Okay, so scrolling down a little bit. So our setup is really simple, pretty much what you would expect. Getting the serial communication set up. Yeah, pins for our cards, for our SD card select pin. A little bit of error handling to kind of make sure that the card gets initialized correctly. We're going to start up the sensors library so we can talk to our two temperature sensors, start the software serial so we can talk to the GPS, and then get our pins for the LEDs set up correctly. So again, nothing fancy here. And then in the loop, all we're going to do, this is really kind of silly, is we're just going to go ahead and, in this case, every 1 second, basically try to interrogate the GPS, get information out of it, and then wait and delay. So we are going to store all that information into this GPS object, which was defined up top. Where do we have that? Here it is. Right, here's our tiny GPS plus object. So I'm calling that GPS. And then we're going to use our software serial to basically, yeah, query the GPS over the software serial pins and get all that information. So again, this is a custom function I wrote that packages up a lot of that information of a lot of those operations to get the data from the GPS and populate this object. And then what I'm going to do is I've got information from the GPS. We are then just going to use the standard Dallas temperature and the one-wire libraries to basically query the two temperature sensors and get their information. So all I'm doing here is just then getting all that information and breaking it out. And same thing here, I am just unpacking a lot of data from that GPS object, or that tiny GPS object, and assigning it to variables, and then I'm just unpacking it here into basically base data types like about the lat, long, the year, month, day, hour, minute, second, speed, course, altitude, number of satellites, and HTOP. So basically just unpacking all of this, and then what I'm going to do is I'm going to go ahead and basically try to create a big giant CSV string. This is probably not the cleanest code in the world, but all I'm going to do is that's all this is doing here, is just basically creating a big CSV. So I'll let you go through this if you want. Feel free to pause the video. One thing I did notice with this, with the Arduino Nano and not having a ton of memory, you can't. Again, I didn't program this the cleanest. I just wanted to get this working, but I end up with issues if I tried to put too much data in each CSV string. So I actually had to leave out information about the GPS course angle. I really don't care about course angle. I can get that after the fact by post-processing, so I have no need to write that down on the fly. So if I leave this in, I end up with memory issues, so I ended up commenting this out so I don't include the GPS course. But I'm pretty much including everything else, and then I am just going to try to use the SD card library to write all that CSV, a single line of that CSV to the file. So that's all I'm doing right here. I'm trying to write it, and as long as the GPS is valid and if I have enough satellites in view, I'm going to start flashing the blue LED on and off to let us know that everything is going hunky-dory and we are successfully writing good data to the card. If it's not, if the GPS is invalid or you don't have enough satellites, I'm just going to leave the LED pin, just basically leave the blue light on constantly. And then actually, if you can't even open the file, if we couldn't even write the SD card, we're going to basically just turn on and start flashing the red LED. So again, that's the code. It's really pretty darn simple. As you can see, less than 300 lines. And again, I will leave a link to this in the description of the video in case you want to download this and use it yourself. So that's a description of the entire setup. Let's go and build it and take a look at what we've got.
All right, so here's my physical build. I'll be the first one to admit that it isn't the prettiest or cleanest, but as you can see, we've got the Arduino here. I've got the GPS module hooked up to the GPS antenna, and then in the back, we've got the MicroSD card reader/writer. So all this should work, and then I've got my little status LEDs that we talked about that I've hooked up. So let's go ahead and plug this guy in and see if this is all gonna work. So there we go, and then now we get the LEDs. So the red LED should come on if there's a problem, so I'm glad that it's off. Now the blue LED is a solid blue, telling us that we're able to write to the card, but we don't have a solid GPS lock. So the solid blue matches sort of the solid green on the GPS module. So hopefully once we do get a valid GPS lock, both the green light on the LED or on the GPS module should start flashing. That will tell us that the GPS module thinks it has a valid lock, and then also we'll get a valid lock down here with the flashing blue. So this will tell us that we're able to get that message onto the Arduino and write it to the SD card. So if we give this a second to get a lock, hopefully both those should start flashing. So we'll give this a second. All right, and there you go. You can see the green LED on the GPS module is flashing, and therefore I also set it up so this blue LED will just periodically flash on and off to tell us that, yeah, we've got a valid GPS signal and we are writing to the card successfully. So this should be pretty much good to go. So tell you what, let's put this in a little enclosure so we can make this a little bit more rugged. All right, so here's my little homemade 3D printed DIY enclosure. As you can see, it just gives some access still to the card and lets you route the wires for the GPS antenna as well as the two temperature sensors externally. So this should be ready to go. If you're interested, I'll leave a link in the video description for where you can download the part files for the enclosure in case you want to print one yourself. But anyway, I think we're ready to rock. Let's go ahead and fire this thing up, power it up, and then go test it out and get a data set. All right, so here we are out at the local park, and we've got the GPS logging system installed in our payload box. So again, this is what we're going to send up in our high altitude weather balloon, but we can use this for testing the GPS logging system. So as you can see, one of the antennas up top is the GPS antenna for our logger, and we've got the temperature sensors kind of sticking out the side so we can get the external temperature, and the other internal temperature sensor is just sitting inside the box so we can measure the inside temperature. So let's go ahead and walk this guy around the park a little bit and just see if we can gather some data and make sure that it's getting logged to the SD card correctly.
All right, so we're back from our little test field excursion, and I've downloaded the CSV file, and here it is. You can see it, log7.csv, and I've just loaded it up in Excel over here, and as you can see, yeah, it looks like it is logging all of that information, right? We've got things like, I think this first column was if the GPS signal is valid, then we had the year, month, day, hour, minute, second, number of satellites, temperature of sensor A, temperature of sensor B, lat long, altitude. I think this was like speed, or no, maybe core. I can't remember exactly what I logged here in this column. And then I think this was HDOP. In fact, you know what we can do instead of me guessing? Let's go over to MATLAB. I wrote some code to basically parse all of this data and plot it. So let's go over here to MATLAB. Let me run this to extract the data, and then I'll run this over here to plot it, and we can take a look at it. And actually, I guess you can see right here. Here's where I put all the information. Yeah, so the first column was, is the GPS valid? Yeah, it looks like I had lat long. Yeah, it was speed. Oh, no, sorry. It was lat long, speed, and then altitude, and then HDOP. But anyway, let's plot this so we can make a little bit more sense of this. And actually, tell you what, let me look at this. I have two plots. Maybe let's put them side by side. Put this on one side, let's put this other one on the other side. So as you can see, I actually started the GPS logger before we even got to the park. So as we were driving there, you can see as we're driving along the road, it looks like it's working, right? This is looking awesome. It's tracking as the car is driving, and then up here is where we get to the park. And let's zoom in a little bit, and yeah, you can see this is looking pretty good. this is where we have set up the table, and we were just looking at it in the video, and then we just walked around the park a little bit. Looks like there's a little hiccup here. I don't remember making this sharp turn. I definitely remember making this little turn and wiggle over here and then coming back. So again, looks like the lat long is looking fairly reasonable. And then if you look at some of the other data that we're logging, like the temperature, this is also looking pretty good. Remember, temperature sensor A was mounted outside the box and B was inside the box. So you can see inside that styrofoam box, the temperature just kept going up and up and up because I think we had all those batteries running. It looks like, this is interesting, temperature sensor A, yeah, the temperature was kind of high and then it went down. I think that's because that's where we got out of the car. And you can actually see over here, look at this, the speed as we're driving to the park, yeah, we're going 30 miles an hour and then we stop and then we get the box out of the car and then we start walking around, we're going slow. So yeah, it looks like this here. This is when we're walking around. That's the time when the temperature went low, and then we put the box back inside the car, and the temperature started climbing up again. So yeah, this is looking pretty darn reasonable. Again, what else is kind of interesting, I think if you look at the number of satellites and also the HDOP, which kind of corresponds to it, as we're inside the car, right, inside this big metal box, the number of satellites you see is not that great, and therefore your HDOP is a little bit high. But as we're outside walking around, yeah, it looks like the number of satellites go up. So again, this looks pretty darn reasonable, and it looks like the logger is functioning correctly. So here's the launch of our Science Club high altitude weather balloon. If you're interested in the details of the project, I'll leave a link to that video in the description. Now, if you watch that video, you'll see that the data logging system worked almost flawlessly during the entire mission. In fact, I was able to download the data and use it to drive these various gauges you see on the screen. And another shameless plug, if you want to see how to do this, feel free to check out my videos on Dashware, which is the software I use for the overlays. What's important for this video is the fact that the GPS functioned all the way up to the burst altitude of the balloon, which was almost 81,000 feet. To be COCOM and compliant, GPS tracking devices are supposed to stop functioning if the object is moving faster than 1,000 knots and is higher than 18,000 meters, which is about 59,000 feet, which is intended to prevent the use of GPS in ICBM type applications. Now, many GPS manufacturers seem to implement this as an OR check in the sense that if either the speed or the altitude exceed these limits, the devices stop operating, which is a problem for our weather balloon because it exceeds the altitude limit but not the speed limit. However, the GPS receiver that we used in this logger appears to implement this as an AND condition, which requires both the speed and the velocity to be above the threshold, which is perfect for our use case. Furthermore, the entire data logging system was actually able to operate in pretty darn low temperatures. The actual logging system was kept inside the styrofoam payload box where it got down to -7 degrees Fahrenheit or -14 Celsius. And the exterior temperature sensor actually measured temperatures all the way down to -46 Fahrenheit or -43 C, and everything seemed to work well. The only time that the data logger stumbled was when the balloon burst at 81,000 feet and it started tumbling as it fell back down to Earth. During this time, it seemed to lose GPS lock, but the temperature sensors kept recording, and it did take a few minutes for it to regain a lock before we had data again.
All right, so there you have it. A pretty easy, cheap, and economical way to build a little logging system that's going to allow you to record things like position and temperature, and as you saw, you can modify the software and hardware to log other sensors as well. So we're pretty happy with this. With that being said, I think this is probably a great spot to leave it. I hope you enjoyed the video, and if so, I also hope you'll consider subscribing to the channel. Surprisingly, if you just scroll a little ways down there and click on that subscribe button, it really does help me continue making these videos. And speaking of the videos, we're going to have a lot of other videos related to Arduino, high altitude weather balloons, things like that. So I hope I'll be able to catch you at one of these future discussions and we can all learn something new together. So until then, I think I'll sign off. Talk to you later. Bye.